to introduce our next speaker, Jason Reum, whom we all know and love. Jason studied at UCLA, receiving a BS in ecology and evolutionary biology with an emphasis in biochemistry. He's originally from South Lake Tahoe, which is where he was introduced to wine through a course series at Lake Tahoe Community College that he describes as an introduction to wine for ski bums. Following this, he worked 2 harvests in the Sierra foothills and most recently worked a harvest in the Okanagan Valley in British Columbia, Canada. Following graduation, Jason plans to work another harvest in Mendocino and hopes to one day work in a cold climate viticulture area where there's easy access to snow skiing. Perhaps this was his inspiration for his literature review topic, because today Jason will be telling you all about how training systems influence frost protection, canopy microclimate, and the fruit composition of interspecific cold hardy cultivars. So take it away, Jason.
That was a wonderful introduction. Thanks, Malenka. Okay, so I guess everyone knows what my topic is. The aim of this whole project was to sort of present and summarize the effects of training and trellising designs in a way that can empower growers in cold climates to produce higher quality fruit in a more sustainable and affordable way. Here's a little bit of an overview of what the presentation is going to include. It's going to start with a short history on the breeding programs for interspecific cold hardy hybrid development, and then move into a general comparisons of sensory profiles for Vitis vinifera wines and hybrid wines. Then it'll take a look at how the effects of climate change are redistributing the world's wine growing regions, and how hybrid grapes carry some genetic advantages to help cope with these changes. Then it'll go a little bit into challenges that are associated uniquely with cold climate viticulture, and I'll wrap up with some practical information on how you can use training systems to mitigate the challenges that are unique to cold climate viticulture. So a little bit of the history for cold hardy hybrids. They're all basically descendants of breeding programs in the 1800s that were originally intended for introducing phylloxera resistance into vinifera vines. Most of the original crossings were done with Native American grapes, a lot of that with Vitis labrusca. And then the second wave aimed at reducing some of the foxy characteristic that had been introduced by labrusca. And then the third wave recrossed that second generation with more vinifera grapes to further try to eliminate the foxy characteristics. Breeding programs are still going on, even though that third wave gave us the cold hardy hybrids that are used commercially today. And current breeding programs are placing a lot of emphasis on creating grapes that are not only improved quality, but also can be grown more sustainably and affordable in cold climates. In general, these non-vinifera wines tend to be a little more green and earthy than pure vinifera wines, but labs are sort of just beginning to identify specifically which compounds are responsible for the conspicuously non-vinifera flavors. So for example, methylenthranolate has been identified as the source of foxiness in Vitis labrusca, and we've known that for a long time, but specific compounds are not quite nailed down for so many of the other non-vinifera flavor profiles. But in general, even if the non-vinifera wines score comparably on fruity or floral characteristics, they tend to have much stronger green and earthy characteristics that distinguish them from vinifera wines. A little bit of a side note, despite all of the possible improvement that can be made in fruit quality and farming techniques that can come along with hybrid grapes, any wines made from these hybrid grapes are going to be up against the challenge of nudging their way into a wine market dominated by vinifera wines. And the global wine market has seen almost exclusively vinifera wines for so long that even if a perfect hybrid grape was bred, it would still be up against the challenge of convincing consumers that just because it's different doesn't mean it's worse. And in fact, in the Midwest, when hybrid wines were tasted alongside vinifera wines, the hybrid wines scored pretty well compared to the vinifera wines, but then if the growing region or the grape was disclosed to the judges, the scores for the hybrid wines fell, which indicates a consumer prejudice against hybrid wines. So again, educating consumers and improving marketing for these grapes will also be necessary to get them into the world wine market. Despite the lack of hybrid wines in grocery stores and wine shops in California, many countries and even regions in the US are already growing plenty of these hybrid wines, especially in the northeastern US, the Midwest, and the Far East. But additionally, the OIV is considering the use of hybrids in established European appellations. And hybrid grapes were actually planted in Bordeaux in 2014 and turned into single varietal wines rather than just being blended in as a test run. Something that I thought was kind of funny was the OIV has rejected some of the names of existing hybrids because they think those names are too close to existing vinifera names and may confuse consumers, but they're still considering it, which is what this quote is showing. A representative from the OIV is basically saying that the OIV is actively thinking about making hybrids sort of a stronger point in particularly as hybrids can make farming more sustainable and environmentally friendly. Okay, on to climate change. In general, with climate change, the world's wine growing regions are moving toward the poles, which is what this upper figure is showing. The shaded blue regions are representing the current wine growing regions around the world, defined as isotherms where the average growing season temperature falls between 12 and 22 degrees Celsius. And then these darker blue lines represent where these isotherms are predicted to migrate by the year 2100. And although climate change is nearly entirely bad, some of the markets at higher latitudes are seeing improvements in their wine industry with increased acreage devoted to grapes and burgeoning wine productions. However, another consequence of poleward expansion brings along increased disease pressure, because a lot of times at these greater latitudes, especially near the coast, these wine growing regions see more precipitation during the growing season, which brings along disease pressure, which is another reason to consider interspecific hybrids. So genetically, hybrids are more tolerant to frosts and diseases, and they can be bred to ripen more quickly, which would be an advantage for anyone trying to grow grapes with a relatively short growing season. This upper bar chart is showing the percent bud damage for vinifera and hybrid varieties at different winter temperatures. So at minus 11 degrees, vinifera gets obliterated. At minus 12 degrees, some of these hybrids are even seeing less than 50% bud damage. So considering these hybrids for planting can make farming more sustainable and affordable, which, back to our marketing side note, could have an advantage for selling these wines as millennials, myself included, the up and coming wine consumer market prefer wines that are more sustainably grown and have fewer inputs and additives. So growing grapes that are genetically more equipped to deal with harsher conditions may appeal to a consumer base. So I think that everything I've kind of talked about around the hybrids with respect to cold climate viticulture can be lumped into two buckets of problems that cold climate viticulturists will need to deal with. The first bucket includes protecting vines from frosts and dangerously cold winter temperatures, which is kind of what this graph on the right is showing. Wines or grapes grown in cold climates can be exposed to cold snaps that are below minus 20 degrees Fahrenheit, or even sustained temperatures below minus 10. And these little color-coded bars down here show where vinifera would be killed in the dormant winter season versus several other hybrids. And you can see that at this cold snap, you've lost all of your vinifera wines, but if you've got hybrids, some of them might still be fighting. The second bucket of challenges, I think, surround achieving full fruit ripeness in a relatively short growing season in these high latitudes where spring and bud break come later and fall and cold temperatures tend to come earlier. So yeah, planting grapes that can ripen more quickly or using viticulture training techniques that can accelerate ripening are both useful to growers. Okay, so what should growers be thinking about as they train their vines to help grapes survive cold climate? Essentially, it all kind of boils down to optimizing canopy microclimate for the grapes. And three parameters that are really important for these growers to think about is the fruit zone height, the canopy density and leaf area ratio, and exposure of the grapes and clusters to sunlight. So we'll get into each one of those a little bit more. With respect to protection from frosts and cold, in general, training vines to be taller will bring more frost protection for the simple reason that cold air will sink and be near the bottom. So as you get further away from the ground, the temperature will be greater. And this study showed that buds on a 2-meter high cordon above the ground stayed 4 degrees Celsius warmer than buds on a 0.9-meter cordon. And they were actually 7 degrees warmer than ground temperature. So if growers particularly need to protect buds or clusters on the shoulder seasons from radiant frosts, they would do well to elevate the fruiting zone. Growers also need to keep in mind leaf area ratio in its relation to vine balance and fruit ripening. Leaf area ratio is just defined as the surface area of leaves exposed to the mass of fresh fruit produced per vine. Howell in 2001 showed that leaf area ratios between 7 and 14 square centimeters per gram of fresh fruit typically indicated a healthy vine balance, where this upper limit, 14, would be better for regions with shorter growing seasons or less sunlight. And that's because a greater leaf area ratio, so more leaves exposed, will basically increase the vine's capacity for photosynthesis, which can increase the rate of carbon fixation and the overall rate of fruit ripening. Growers who are planting vines and want to increase leaf area ratio, in my opinion, should think about dividing their canopy, because with a divided canopy comes reduced canopy density and an increased number of leaves that are actually exposed to the sunlight. So an important note to keep in mind about this, though, is you can divide your canopy horizontally or vertically, and both of those types of division will increase leaf area ratio and reduce canopy density. But with vertical division, the lower cordon and the upper cordon will ripen at different rates. And in a cold climate, a lower cordon will be more susceptible to damage through frosts and freezing. So finally, exposing clusters to sunlight is a good idea, as that can accelerate ripening and improve fruit quality. In these cold climates, growers often face the challenge of not accumulating enough sugar through the growing season and being left picking grapes with extremely high titratable acidities. But if you can warm the clusters and the berries up, you can possibly upregulate light-dependent enzymes involved in sugar metabolism, and exposure to sunlight certainly increases the rate of malic acid degradation. So reducing canopy density and allowing more light to hit the grapes and berries can warm them up and possibly increase sugar metabolism and increase acid degradation. So, summaries and takeaways. Climate change is inevitable and driving wine growing regions poleward, which usually brings along an increased risk of cold damage and disease pressure. Cold hardy interspecific hybrids are one tool that can deal with this, as those grapes come more genetically equipped to deal with disease and cold, perhaps making farming in cold climate regions more sustainable and affordable. With respect to addressing specifically challenges unique to cold climate viticulture, growers ought to train their vines to be taller, to move the buds and clusters further away from cold ground temperatures. Growers should keep in mind leaf area ratio with respect to vine balance and fruit ripening as a way to increase photosynthetic capacity and accelerate fruit ripening. Growers should reduce canopy density and increase sun exposure to berries to potentially upregulate sugar metabolism and certainly accelerate acid degradation. So if anyone was planning on, I guess, driving north tomorrow and buying a vineyard, I would probably tell them to consider training their vines to be tall and horizontally divided, because that sort of trellis system checks all the boxes that I've talked about so far. Oh, record time. Okay, so thank you to my cohort. Malenka said it better than I could ever hope to. We have a terrific cohort. Thanks to the VEN department faculty and staff, Dario, who's been a great advisor and keeps all of us sane, Con Kurteral, my literature review advisor, the chem department for giving me TA ships last year, and the Arojo family, Sacramento Home Winemakers Club, Wine Spectator, and the John D. Cole Memorial Scholarship Committee, all for helping me fund my education. So with that, are there any questions?
Hey, Jason, this is Mark. I was wondering if you'd had a chance to taste any of the vinifera other wine made from those grapes.
Yeah, anyone who went to the Vitus with the Atlantic seaboard would have gotten to taste those. They had a bunch of them, and they're all, even to my pretty new palate, they're all obviously different than vinifera wines. But I wouldn't say it's all bad.
Jason, I have a question for you, which is outside of viticulture, but how much you think also winemaking practices should adapt to these non-vinifera hybrids? How much do we know how much margin of improvement there is there in the winemaking side of the story?
Oh, well, I'm not positive. I wasn't looking into that, but from the little like titles that I saw or PowerPoint presentations that I read through, people were recommending different fermentation temperatures or different lengths of fermentation or different yeast species to ferment with, basically as a way to kind of manipulate the non-vinifera profiles or perhaps encourage more color extraction from some of the grapes. So yeah, I don't know very much about that, but I know that people are of the opinion that winemaking with these grapes, if you want to try to mimic a vinifera quality wine, the winemaking should be done a little bit differently in some areas.
Thank you.